This is Red. Red is a little robot that I made using... Oh, there he goes talking. It's made using the Circuit Playground Express, a Cricket for the Circuit Playground Express, HSR04s, I believe they are, which is the distance sensors. Clearly he wants to be moving right now. He has old RAM chips for arms. It has 2 servos inside for the drive wheels. These are 90-degree servos. These are continuous servos that I have plus or minus. And this is an old T-tin. And I left it so you can take the top off. If you look inside, so there's the 2 servos, and I've just got a whole lot of glue in there. And I have little Lego wheels, which are actually just on a standard Lego spinny. And this is so that it can kind of spin around. And let me show you how it works. When you first turn it on, it says hello. And then what's happening is it is constantly sending at a pulse and checking the distance. And it's seeing for when you wave. So in demonstrating all of that, I ended up disconnecting one of the wires on the HCSR04, and it wasn't reading anything. So now it is. And there it goes, it's dancing. Well, it seems to be low on battery, so I don't know if it's just that the AA's need to be recharged or what. But it seems to get stuck on that, so it gives motivational things, says you can do it. You can see it's also a Harry Potter fan. So basically it's programming is set that after a certain amount of waves, it will execute a random sort of command. So let's go through what that code looks like. All right, I'm going to turn this off just briefly while I run through the code, just so that it doesn't constantly go off while I'm actually coding. So this was programmed in CircuitPython, which is a version of Python, which is runnable on embedded devices, such as the Circuit Playground, or other Arduino compatible type devices. This is Mu, which is a freely available code editor. So I'm importing Time, the Adafruit Cricket, and Circuit Playground Express boards, the Adafruit HCSR04. I'm not actually using the Adafruit HCSR04, but it's the only HCSR04 library that is available in CircuitPython. If you're not sure what HCSR04 stands for, it's the device that reads distance using sound waves. So it's the little sonar detection in the front. Board math and random. So I initialize the sonar and I have it connected through pins A3 and A2 through alligator clips. The alligator clips, for some reason, the contacts aren't great. So if I was going to make this more final version, I would certainly be using nuts and bolts to actually screw on and possibly even solder the connections. Reset the servo angles. So what's great about the Circuit Playground Express and the Cricket is it has some really great libraries for handling both servos and motors and things like that. So as long as the servos are just connected into the board in the right way, this is all the code you need to give it a command. So in this case, I'm resetting the 2 arms, which is the main servos, to 90 degrees, which is straight out. And the left and right wheel are the DC motor 1 and DC motor 2. And I have a direction on them because my 2 drive wheels are in different directions. So if I told them both to go forward, then it would just spin around in a constant circle. So I just kind of have this here. So if you build this, but you build it slightly differently, and you want to reuse the code, you can reuse the code. All you need to do is change if it's a -1 or a +1. And that way, all the code stays the same, but you can have a slightly different configuration on your drive wheels. Then I have functions for everything I want it to do. So for saying hello, we have the wave file that plays, but there's also another one where it just kind of raises its hand and waves. And this is just 4 different tones, and then I move the hand up, wiggle the hand a little bit, and then move it back down. I have a spin left. It throttles both the left and the right wheel just for about half a second, and then it throttles them and it stops. Spin right does exactly the same thing, just in reverse. I have a function for doing the monkey. For those of you who don't know, the monkey is a dance where you take your arms and one goes up and one goes down, and you do that over and over again. So in this case, it makes one go up and one go down. Now, as you see, the angles are both 160 here and both 20 here, and that's because I have my servos rotated. So one servo is going out the left side and one's going out the right side. So when you translate that and flip that, that means they are both inverted. So this is how you would make sure that they're different, even though they look the same. I have a function dance, which is just spin left, spin right, spin right, spin left. Left and right cancel each other out. Left and right and left cancel each other out, so it always ends up in the middle. It does the monkey, and then it returns back to 90-90. I have Hedwig's theme, so that it's a Harry Potter fan, so it plays the song. So here are the notes. Here is the translation of those notes. Now, these notes is, I think, what I did originally, and then I looked it up again, and this is what I went with. So you can kind of ignore these comments, but it sounds different, so it's up to you. You can always change it. And then I play a little wave file saying Wingardium Leviosa, and it moves its arm up, casts a little spell, and then moves the arm back. When you first turn it on, it plays the file hello.wave, and it picks a random action, which is random int. So now the checking for the wave. Now it's actually, there's a few ways you could do it, and there might be more efficient ways, but this is kind of how I did it. So first I figure out what the distance is, and the distance is going to be something, I believe, in centimeters. And then I append it to an array. So I have an array of visuals. So my visuals, really what it comes down to is, I guess it's distances. And then if I have 10 items in my distance array, so that's enough data points, then I'm going to pop off the first item. So it's going to keep the 10 most recent ones. And then I'm going to measure how many high ones and how many low ones. So a high one, in this case, is more than 30 centimeters, and a low one is less than 20 centimeters. So if you think about a wave is going to be, when you're waving in front of something, it's going to be a very large discrepancy. So it's going to be very close, very far, very close. So the thought is, if someone's walking towards this, that wouldn't set it off. Whereas if someone's clearly waving, that would. Now, less than 20 centimeters is pretty close, so you need to wave pretty close. But that's pretty much how it does it. So it counts the amount of lows and the amount of highs that are in the last 10 measurements. And my measurements are happening once every 0.2 seconds. So that means I am looking for at least 5 highs and at least 2 lows within 2 seconds. So 1, 2. So that's a pretty fast wave, but not too much. This can definitely be tweaked and optimized. And then if there's at least 2 lows and at least 5 highs, then we will do a random action. So it picks a random number, and this I commented out just so that I can clean things up. This I commented out just so it's not running while I'm actually doing this and distracting me. And then if the action is 0, say hello. If the action is 1, dance. If the action is 2, then play the file do it, which says you can do it. And if action is 3, play Hedwig's theme, and then reset the visuals. So what this is doing is, if it actually measures this, then scrap it and wait for 10 more actions before you do something. Otherwise, in theory, if you're waving, it could just keep acting over and over and over and over and over again. So that kind of cleans it up. And if there's an exception, so if it can't actually get any visuals, then it says, retrying, and then it sleeps. I've played with this at like 0.3 seconds. I played with it at 0.1. It's been finicky kind of anywhere, but it works as a concept. So it's going to V battery on the Circuit Playground Express, which is how it gets 5 volts, and then it comes into ground. And the only things I have connected into the Cricket are the 2 motors, so the 2 motors for the drive wheels, and the 2 servos. So there's still 2 servo slots, there's still the capacitive touch, there's still a whole bunch available on the Cricket, should you want to expand this type of robot. But I hope you enjoyed, and if you like this, please put a like on the video. Feel free to subscribe. I do a lot of different content like this, and I want to do a lot more educational content. And additionally, I have written a short backstory for Red, and if you would like to read that, I will have a link below to the audio version of that where I read it out loud, as well as the text version, and if you wish to just kind of read it yourself. So thank you very much. Have a wonderful day, and keep making. Bye.